number 60 on page 164 is another precipitation reaction. In this reaction, we are going to be reacting silver nitrate, which is aqueous, given the concentration in the problem, and calcium chloride, also an aqueous substance. The products of this reaction will be silver chloride and calcium nitrate. We have to check our solubility rules to determine which one of these products will be the insoluble precipitate. When you do that, group 17 is in the NAGSAG rules. Group 17 is soluble unless it is with PMS, which is lead, mercury, or silver. So this is going to be my solid precipitate. This is my aqueous substance. You are given the concentration and the volume of each of your reactants. When we look at this, you have 0.2 molar silver nitrate. How many moles, then, if you have 100 mils, or 0.1 liters of silver nitrate do you have? When you calculate this, you get 0.020 moles of silver nitrate to start. You repeat the same process with your calcium chloride. You have 0.15 molar calcium chloride. How many moles of calcium chloride do you start with if you have 0.1 liters, again, of calcium chloride? When you do this calculation, you have 0.015 moles of calcium chloride to start. Again, I forgot to balance. So balancing, I have 2 here and 2 here to make this a balanced chemical equation. So to go through which substance is the limiting reactant, we have to say, okay, if I use all of the silver nitrate up, how much of the silver chloride would I use up? You can see that if you are starting with 0.020 moles of AgNO3, you will get an equal amount, 0.020 moles of silver chloride produced. If you work with the calcium chloride, it's 0.015 moles of the calcium chloride. In my next factor, the ratio is 1 calcium chloride to 2 moles of silver chloride, and so you can see you'll get 0.030 moles of silver chloride. The reactant that produces less product is my limiting reactant, which makes my silver nitrate the limiting reactant. I will use this then to figure out how much of my solid precipitate will form. And so I'm going to take my moles of silver chloride and get that to grams of silver chloride. And the molar mass is 143.4 grams. When you calculate, you will find out that you get 2.9 grams of silver chloride solid produced. Okay? Now that is only the amount of solid produced. It's not all of the other ions in solution. We know that we're going to have excess calcium chloride because that was our excess reactant. So we're going to have excess calcium ions. We're going to have excess chloride ions. The nitrate ions that we started with in the silver nitrate are not being used in the chloride reaction or making the silver chloride. So those will also be floating around in solution. So we have a lot of other ions to consider. Sometimes a helpful thought is to consider, everything that's going into your reaction and everything that's being produced. I'm putting silver ions in there. I'm putting nitrate ions in there. I'm putting calcium ions in there. I'm putting chloride ions in there. And all of those things are going in there. Only the silver and the chloride are reacting to produce a solid at the bottom. The nitrate and the calcium are spectator ions in this aqueous solution. So a picture is sometimes a very helpful place to start to kind of get an idea of the ions in solution. So to answer this question, calculate the concentration of each ion remaining in solution after precipitation, I have to work with the net ionic equation. And so actually I'm going to go back and erase a little bit here because I already know that this is my limiting reactant. I know that I'm going to produce this many grams. So I'm just going to write my net ionic equation is Ag plus Cl minus producing AgCl solid. Okay? We know that the silver is the limiting reactant from up here. So I will have no silver left in solution. However, chloride is coming from my excess reactant. So there is going to be excess chloride ions. How many excess chloride ions? Well, we know that 0.02 moles of this was produced. That means 0.02 moles of chloride reacted. We started with 0.015 moles of calcium chloride, but how many moles of just chloride? We see that there are 2 chlorides for every 1 calcium chloride. So I started with 0.03 moles of calcium, or of just the chloride. And so to figure out how many moles that were not reacted, I take the difference, 0.03 moles minus the 0.02 that did react, and I'll end up with 0.01 moles of chloride that did not react. If I want concentration, I have to take my moles over my volume, but remember I added 2 of these aqueous solutions together, so that's 0.2 liters. And for my chloride, I have a concentration of 0.050 molar is the concentration for the chloride. Now, that chloride was part of the reactant. The calcium and the nitrate didn't react at all. Nothing happened to them when they went through the reaction. So I go back to my original here, and I have 0.02 moles of nitrate. Let's say 0.02 moles of nitrate minus, what is the concentration? Again, moles over total volume. I put 100 mils with 100 mils, and so the concentration of the nitrate ends up being 0.10 molar, NO3 minus. And I repeat that same process with the calcium. The calcium went unreacted the whole time. I started with 0.015 moles of calcium, or calcium chloride, which means I have 0.015 moles of calcium. Nothing happened to it as the reaction proceeded. So I have 0.015 moles of calcium over the volume, again added 100 mils with 100 mils. So the concentration of the calcium is 0.075 molar Ca2 plus. I think that answers all of the questions. You maybe want to box in. Here's the chloride, here's the calcium, and here is the nitrate. Hopefully your page is a little neater than mine because I have limited space, but you can take as much space as you need. Good luck.